IGCSE 0625/42, May-June 2024, Paper 4, Theory Extended, Paper Walkthrough. The first question: a load is suspended from a thread. The vertical force on the thread due to the load is 0.75 newtons. Calculate the mass of the load. So in this question we are asked to find the mass, so we know the force. So we can use this equation where we have to rearrange to find the mass. And we know that the weight, or basically the load, is 0.75 newtons. So we get the value for 9.8 for acceleration from our instructions. So we're going to use 9.8. That's going to be 0.077 kilograms. Figure 1.1 shows the load suspended from the thread. The wire is attached to the load at point X and pulled horizontally to the right. So there's a wire attached, and it's pulled horizontally to the right. So by drawing a scale diagram or by calculation, we have to determine the resultant force at X due to the load and due to the tension in the wire. So this is a rectangle, and this would be the resultant. So by calculation, I'll be finding the resultant force. So removing the square root, it's 1.4 newtons, and they're asking the direction relative to the vertical. So we are supposed to measure this angle, and you will have to write that angle here. For this question you have to draw a scale diagram, so you'll be able to measure this angle. Force may produce changes in the size and the shape of an object. State other two changes that a force may produce. So you can write any two from this list. Question 2. Define acceleration. Acceleration is a change in velocity per unit time, or the rate of change of velocity. A train has a given mass, and the train accelerates at a speed of 1.1 meters per second. Calculate the time taken for the train to increase its speed from 15 meters per second to 28 meters per second. So in this case, we are going to use the equation acceleration is equal to final velocity minus initial velocity divided by time, where we have the final velocity, which is 28, minus initial velocity, which is 15, divided by the acceleration, and that would give us the time. That's 11.8 seconds. So we'll round it off to 2SF, 12 seconds. Calculate the force required to produce an acceleration of 1.1 meters per second. For this, we are going to use the equation force is equal to mass into acceleration, and the mass is 520,000 kilograms. The acceleration is 1.1. So the force will be, it'll be 570,000 newtons. The train uses electric motors. Explain why the force on the train due to the motor is greater than the value calculated. So here we don't have any account for friction. So there's additional frictional forces and drag and air resistance. Therefore, the force on the motor is greater than the value we calculated. The third question. A student drops a heavy ball from a vertical height of 1.8 meters above the ground. The ball then falls to the ground and it does not bounce after hitting the ground. So there's a ball and it's at 1.8 meters from the ground. And now the student drops this ball. Describe the transfers of energy between the stores from when the ball begins to fall to when it reaches the ground. So the ball initially has gravitational potential energy because it's at 1.8 meters from the ground, and as the ball falls, uh, the gravitational potential energy would be converted to kinetic energy, and when it reaches to the ground, after hitting the ground the ball does not bounce, so the energy it has, so basically the kinetic energy the ball had would be converted to some other form of energy, which is thermal energy. So I've the answer here, you can read it. Okay, part B. Calculate the maximum speed of the ball, ignore the air resistance. So in this question, we can use this equation. Gravitational potential energy lost is equal to kinetic energy gained. So this is the equation for gravitational potential energy, and this is for kinetic energy. So this is quite a common question where you have to use this concept, and as you can see in this question, masses are not given, but when we use this concept we have the mass on both sides, therefore we don't need the mass, and we have the height, and that's 1.8 meters, so we can use that and we can find the maximum speed. So and that's it for question number 3. Question 4. State 2 ways that evaporation differs from boiling. So boiling happens throughout the liquid. Evaporation takes place at any temperature. But boiling, there's a specific temperature where boiling happens. The part of the container used to store a mixture of liquids and gases. Figure 4.1 shows a part of a container used to store a mixture of liquids and gases. The temperature of liquid oxygen is minus 160 degrees Celsius. Determine the temperature of the liquid in Kelvin. So to convert from Celsius to Kelvin, you have to add 273 to minus 160. And the unit is given. The container is made up of steel, and there's a vacuum between the inner and outer walls. The outer wall of the container is at room temperature. State 2 methods of thermal energy transfer that a vacuum prevents: conduction and convection. Describe in terms of particles how a gas exerts a pressure on the wall of its container. Gas particles are constantly moving and collide with the walls of the container. These collisions exert a force on the wall because the particles change momentum when they hit the walls. Since pressure is force per unit area, these repeated collisions result in a pressure being exerted on the walls of the container. So these are the 3 points you have to include in your answer. Question 5. Figure 5.1 shows a ray of yellow light incident on the glass prism A, B, C. Part A. Explain why the ray of light does not change in direction when it enters the prism. So you can see the yellow light entering the prism, and the ray travels along a normal. The angle of incidence is 0, therefore the ray does not change in a direction. Part B. The critical angle for the glass is 42 degrees. Calculate the refractive index of the glass. So we have the critical angle, so we can use the equation n is equal to 1 by sine c, and sine c, where c is the critical angle, so refractive index will be 1 by sine 42, and refractive index will be 1.5. On figure 5.1, continue the path of light through the prism and after it leaves the prism. So here we have to draw the normal, and this will be the angle of incidence. So in the previous part we have they have given the critical angle for glass, which is 42 degrees, and this angle is greater than 42 degrees. So, well, there are 3 possibilities. So one is that the ray could travel like this, and the other possibility is it could travel like this, and this is the third possibility. So here in this case, angle of incidence is likely greater than 42 degrees. So when the angle of incidence is greater than the critical angle, total internal reflection would take place. So this would be wrong, and this would be wrong, and this would be the correct one. So from here we have to continue this path, something like this. So these 2 angles would be the same as its reflection, and here it would be here the ray would pass through the normal, so there won't be any change in direction. Internet data can be transferred using infrared waves and optical fibers. State 2 advantage of using optical fibers to transfer data. High rates of data transmission and little signal loss. Question 6. A sound wave travels through air. Figure 6.1 shows the pressure time graph for the air at one place. So we have pressure and we have time, and part 1 we are asked to label 1 point indicating the compression and 1 point indicating the rarefaction. So compression is the high pressure regions, so here we have maximum pressure, so any one of these points we can mark it as the compression. And rarefactions have the lowest pressure, so any of these regions can be labeled as the rarefaction. Explain why this graph cannot be used to find the wavelength of the sound wave. So this graph has pressure and time, and the graph does not show variation with displacement, therefore we cannot use this graph to find the wavelength. The sound becomes louder and of low pitch. State what happens to amplitude and the frequency. So here the pitch decreases and the sound becomes louder. So in that case the amplitude would increase and the frequency would decrease. So it would look something like this. For example, if they ask us to sketch, this would be the graph. This is lower frequency and a higher amplitude than the previous one. Part B. A sound of frequency 13 kHz is transmitted through the water. The speed of sound in water is 1500 meters. Calculate the wavelength. So In order to calculate the wavelength, we can use this equation. V is equal to frequency multiplied by the wavelength. So we need the wavelength, so it's the velocity divided by the frequency. The velocity is 1500 divided by the frequency. It is in kilohertz, so we have to convert it. The wavelength is 0.12 meters. State the approximate speed of sound and air. 330 meters per second.